Solid Edge ST8 strengthens its industry leadership in efficient 3D product design. This latest release delivers intuitive electrical system routing capabilities and documentation enhancements. In this demonstration, we'll continue to work with a new prototype of our recovery robot, routing electrical wires in bundles using previously imported wiring schematics within the current layout of all the physical components. We'll also complete a nail board for the resulting harness. Now that we imported the wires and started to create physical harnesses out of them, we'll route the electrical wires on one side of the robot. We're using new motors on this prototype, so we have to define them as electrical components and assign terminals. New to ST8, all definitions and terminals can be created as product manufacturing information, PMI. These part-level annotations are now read and used by wire creation and routing functions, a huge benefit. Solid Edge ST8 provides the ability to automatically route wires and cables through existing clips, saving time and effort. In fact, wires can be associated with any circular faces, even partial rounds. ST8 introduces the ability to reuse existing paths, and here we'll bundle other wires using the path of the longest cable. We now have the ability to split a path at any location along the curve. We'll define a split across from our motor terminals and another on the control point on the edge of the clip, ensuring proper flow into the motor. Routing paths as 3D sketch curves provide maximum design flexibility and a fraction of the time, as both control points and blue dots can be moved to modify the path shape. A split can serve as a beginning point of a bundle containing several runs to create the desired connectivity. Now that the paths have been routed, we'll place wires. Solid Edge ST8 provides handy filters which narrow down key point selection by identifying terminals defined with PMI. Direction of wires is important, and Solid Edge ensures we get the correct input and output direction the first time, though changes are always easy and fast. Next, we'll bundle these wires to create an orderly set. Each bundle is defined by the collection of wires, including those coming from a split, and color to differentiate bundles by function or some other criteria. Solid Edge calculates the diameter of the cables and bundles based off of quantity and size of the associated wires. You may need to move a bundle to avoid interference or to lessen the impacts of heat or vibration. Solid Edge handles changes seamlessly. Finally, we need to connect our second converter component. To accomplish this, we'll use ST8's new splice functionality to connect new wires, or in this case an entire cable, into the existing cable. Note the sphere representing the splice feature. We'll quickly route new wires from the converter's terminals to the splice feature. Documentation of the harness's cables and bundles leverages Solid Edge's industry-leading drafting functionality. Here we'll finalize our electrical design by updating a nail board drawing. Solid Edge provides true nail board representations for layouts and connector tables. ST8 introduces splice representations on the nail boards. Watch as we place a callout to show the definition of the bundle and its corresponding splice. Traditional nail board design requires a 1:1 scale so the actual harness can be assembled on top of the nail board. ST8 provides nail board scalability to meet the need for representation on a standard drawing size. Watch as we create an A4 sheet and scale down the nail board to fit. We'll place the conductor table on additional sheets to complete documentation of the overall system. These enhancements facilitate electrical system design for both manufacturing and documentation. Just one more way that Solid Edge accelerates product development and ensures you get the job done right the first time. Solid Edge. Design better.